one of them, go through one of them in today's class. All right. So the first thing we are going to do is talk about the filing system, which is the how we store the file and the directory in Unix. Okay. So we are going to write a program which is similar to ls or list list the file and directory, and also we will call this one is fsize. It's a little bit different than the ls, but it still provides all the file and directory underneath with their size. All right. So it works recursively, means if you have a subdirectory underneath, it will open up those subdirectory and print out all the things underneath. Okay, so let's first look at how the file is stored in the system, in the Unix system. So essentially, we're using a dictionary, which including two things. One is the inode number. Okay, basically, you can imagine that is a pointer number or a memory address or something like that. It's like an integer number. And then it has the file name itself. All right. We'll look at some example later, but that's basically a directory contain two things, a number and the file name. Then in the Unix, we can use ls-i to show us the inode number. The I means index, okay, index node number, all right. And we can also using this stat file name to display the detailed index information. Okay, the index number is just a number linked to a bunch of information. All right, so we can look at those information using this stat file name. So this is how this directory is defined as a structure, right? And it's called directory. And then first one is a special integer called d_ino. And the second one is the array to store the file name. All right. We're going to make a custom version of our stack function ourselves. So this is the input of the stack function, right? So the stack function will take two things. One is this name of the file. The other is a pointer's address to this buffer buffer structure. Okay, we'll look at that a little bit later. Okay, so this is this buffer structure look like. So that contains a lot of information. For example, what's the device ID is, what's the node number, what's the mode. This is the mode bit. What kind of the mode means it's read or write, right? Something like that. And then you have this number of links to the file. Who is the owner of this user, owner of the user and owner of the group ID, and there will be a special flag for special file and the size of the file. All right. So essentially, what happened is, first of all, we will have a inode number, right? Inode number attached with a file name is a structure itself, right? That's a directory. And then this inode information structure is recording everything, every metadata about this file. So those are two separate files. So you can imagine in the first file, as we talk about the directory, it has the inode ID, inode number, as well as the file name. You can use the same structure to create a duplicate of the same file. Okay, what does that mean? So share the other screen. I'll just share the entire screen. All right. So let's say one is the inode number ID, right? And then the other is name, file name. So let's assume we have a number like this. This is inode number. Hopefully I should do this. Then I could have the name is readme.txt, right? So that's all is stored in this directory structure. And then inside your node information, you can have a bunch of information such as the file size, the access mode, file type, so on and so forth. All right. What I'm trying to tell you is we could have another directory. That's another directory. And has the in node is the same. But you could name it a different things. Right. So here is readme.txt. This one is log.txt. They're actually pointing at the same thing. All right. So this is essentially what this number of links to the file means, right? You could have multiple file linked to the same thing, all right? So by default, you can imagine there'll be one, but sometimes it could be two or three if needed. Okay, here is a bunch of flags, all right? So at one point, we wanted to determine the type of the file, right? The type of file means either it is a directory or it's a regular file or sometimes called a special character or it's a special block. Okay, so there are 4 different type of it. And then we have this thing, it's called type of file. All right, so do you know, anyone have a guess, like why is there having those different names? Is any reason they name those things? Like one is like 16 and 4 and 2 and 6 and 1, 10. Have a guess why they're using those values? Yeah, for flagging. Yeah. So that's right. So let me show you what that actually means. So if we look at this first part, right? This is the flag used to identify the file type. And if we convert it into the binary, the first bit is just to tell you this is octal, so we ignore that. Second is 1, so it will be 001. The 6 will become 110, and the remaining will be all 0, right? And then we grab another value, which is, I think that was the directory, right? So if we want to see if this file is a directory or not, so when we convert this guy to the binary, the first 0 will be ignored, second 0 will be here, 4 will be 100, and the remaining will be all 0, right? So you can see we're essentially using this middle one as a flag to determine if it is a directory or not, right? So if this has a 1 flag over here, right? So whatever file type flag we got, we will first using an AND operation with this flag, right? So we only look at those 3 things here, right? Then we use another AND operation to compare to this directory flag. If it's true, that means yes, it is a directory. Okay, this is how this is set up. All right, so let's take another example. Is this maybe the regular file? Let's try the regular file instead. So if we try this as a regular file, is this one, right? So there will be 001, and all the remaining will be 0. So I just copy and paste. Oh, don't do that. Right. So we're essentially using this first second bits as a flag for determining if it's a file. Right. File flag, and this is directory flag. Yeah. All right. Hopefully that makes sense. Go back to our slides. Yeah, the same idea applied to the read and write and execute permission, but rather they're using the lower bits, right, to determine that. All right, so let's try that in the Linux system ourselves first. Right, well, let's see how it actually works in the Linux. Then later on, we're going to try to program, or at least understand the program underneath, the code underneath how it works. All right, so let's open up this link in our slides. This is like a online simulator for let you play with a UNIX system or Linux system rather. They're very similar, at least for those tasks. So you just hit on the start, and now you can start to type something. Okay, the session will terminate after 30 minutes, which should be sufficient for your practice purpose. All right, you can go ahead and open it up. Yeah, let's try this out together. So I have the command window on the one side, and I have my slides on the other side, so I can look at the what kind of command we're going to use. Yeah, take your time. Open the slides, go to page number 8 to open this link, and then we'll try that out together. All right, so this is a very typical Linux system, which you don't have a graphical user interface, right? You have just like one line. If you're actually running on a real computer, that's all you see on the computer, this like this black part. So all the thing you have to do is have to type a command inside of it, right? So the first command we're going to do is just to create a directory, because we have nothing right now. So you can just say mkdir, which is making directory. And then you can just call it whatever you like. So in my case, I call it my test directory, right? You can use the exact same name or use your own name. That doesn't matter. And after you type your, well, make sure there's no space in the name. Okay, that's important. Okay, right? Remember, when we making our program, every space will be considered as a splitter for the argument you put into the your function, right? So now enter. You didn't see any error message. It means it works. All right. If you see any error message, that something is wrong. All right. So we have made this one. Now we're going to do is we will get inside this directory, and we'll create a bunch of files inside of it. All right. So we'll cd cd means change directory. And then we'll type the name of your directory. You can just type a few letters at the beginning, then you just hit tab. It will automatically complete the full name for you, assuming that's a unique name, right? If it's not unique, it won't do it. You have to keep typing until you have enough power to be unique. Then you click on the tab. And now you go enter. One thing you realize that before it was like have only this sign. Now it's showing you you're under this directory now, right? That means before you're under the home directory. Now you're inside this directory. All right, assume that's very straightforward. So the next step is we'll create 3 empty file. All right, so use the function called touch. So touch, and you can go file1.txt. Now you have to put space, right? This is separating another file. File2.txt, file3.txt. You can go on and on, right? Don't even need to be txt. You can have any extension as well. That's just a name as a string. So once you've done all of them, you just go enter. So this effectively create you 3 files underneath. Again, you can choose whatever name you like. Okay, whatever extension, whatever name you like. All right. The reason we do that is we want to show how this list works, right? So we use ls. Okay, if you use ls only, you enter, it will show you all the file under this directory, right? That's those 3 we just created. But if we go with the argument -i, right, that will show us the inode information, what we just talked about, right? You can see here the inode will give you, this is the inode ID, first one, and then this is the file name, right? And another inode ID, file name, inode ID, file name, right? So that's exactly the structure we just talked about earlier, right? So if we want to see specific information inside this inode information structure, so we can use stat, then file1.txt. So that will show us specific information about one particular file. Right? For example, the file name is file1.txt, file size is 0 because it's empty, block is 0, IO block, whatever that is. Device ID, inode ID, links, right? There's only one file link to it. And also we have access. Remember we talked about this access last time, right? This was the 6 means. 6 means it is read and write, writable but not executable, right? And the 4 means it's only readable to the people outside your user group, right? And also have a bunch of information such as access date, modified date, change date, and birth date, which is created. It will be, those information could slightly be different from Unix system to system, all right? If we use the other command, ls-l, that will show us all the permissions for every file, all right? Every file under your directory. Any questions so far? All good? Okay. One more thing we can try is to modify the permission. Okay, so we can use the chomd, so that's changing the permission to a particular file, 444. That means read-only for every user, and the file 1.txt. All right, so now if we use ls -L again, you can see the permission has been changed. Right. So for file 1, it is read only for everything, right? While before it is like read and writable. All right. Yeah. Again, if you're ever going to learn about Unix system, in some of the tutorial it asks you to install some software package. At one point, it will tell you that, oh, you should change the permission of one file to 777. All right. First of all, this could be wrong. But second, it might work. It might help you to install the whole thing, but be very careful to change them back after you install everything. Because if you do so, and that will means like this particular file can do anything, right? Any code writing to this one, you can execute it. You can destroy the whole system, right? This is very dangerous. What happened? I did is I used the arrow key up and down to retrieve the command I have entered before. So at the beginning, it was nothing, right? If I click on the arrow key up, it will bring me the last command I just typed in. And I keep doing that. It will show me all the commands I have ever typed in this session. All right, this is very convenient, especially sometimes you made a typo in your command and you have to retype everything. So this will bring you up the previous command right away. Okay, so next part is, okay, we're going to go back a parent level. So cd dot means the parent folder. So we just cd space dot. Now you can see we're get out of our my test directory, right? So we're coming to the home directory. Now we use this command called find and then my test directory. You can use tab. You can save a lot of time on typing the whole thing. And this command will list all the directory underneath as well as all the file underneath. So that's more or less what we're going to make using basic C program ourselves. All right. So before we finish this thing, there's two more command you can try to use. One is the delete function. So you go cd into this directory. We back to our directory just made again. We're inside our test directory. Use rm and file file3.txt. Right now, if you use the list again, you see there's only two files now. Right? We have removed one of the file. So what happened inside this remove is we remove it from the file system. We basically dislink the inode ID apart from this file, right? Actually, the information inside this file is still there on the hard drive, but just it's removed from the file system. All right, so the other thing is we can go back to destroy the whole directory, which might not be possible because it has file inside. Let me try. It might work, depending on the system. So we use cd back and then remove directory. Yeah, it doesn't work because it's not empty. All right, so that's like a safety lock. So if you want to remove a directory, you have to say delete every single file underneath beforehand. Then you can remove the file, remove the directory. All right, that's all the tutorial part on the Unix system. We're not getting deeper on how to use this one, but rather help you understand how the operation system works using the C, right? Any questions? There are a list of commands we just used. Make directory, change directory, create empty file, list file with their inode ID, stack is getting the detail inode information, change file permission, remove directory, and search for all the file and directory underneath a given directory. Any question? Okay, if that's not the case, hopefully you understand what we're looking for. And now let's see how that actually works using this our C command. This is the fsize. What is it's doing the very similar thing to the find we just tried. All right. So this whole program has multiple parts. Let's look at the main function first. So the main function is only just to read all the arguments. Ideally, we have two scenarios. One is if it's nothing append to it, it will read the current directory. Okay, so in that case, we'll pass one dot into our function fsize. So the dot means the current directory. Two dot means the parent directory. All right. But if there's an argument attached to it, that means we want to read a specific directory. So we will pass that directory into this fsize function. Okay, again, this is pretty standard arguments manipulation. So I'm not going into much details here. Okay, the fsize function is a little bit complicated. So first is we're going to check if this is an error message with it. It means like it's no inode information at all, right? If we call this stack function and with the name as well as this structure to store all the information, if this function return -1, that means it cannot find that information at all based on the file name. So we'll print out the error message and return. And now assume it does. Now we store every inode information inside this structure, right? Stack buffer. Then we check the mode of it, right? We use the AND operation with the file type, right? That's the one that's the 016000, right? That's the kind of thing. And then we compare it to if that's the same as the directory flag. We just remember. So we use an AND operation with this guy per here, right, to separate out only those 3 bits, and then we'll compare it to this guy, right? If that's equal, it means it has this flag is a 1. That means this is a directory file. And if that's the directory file, we have another function to handle the directory because it's become more complicated because you might go deeper and deeper into subdirectory. But if it's not directory, it's actually easier. We just go print out the file is a file. Yeah, this is just to print out the size of the file and the file name. Okay, now let's look at the most complicated part, which is the directory function. So the directory function handles each file in a directory one at a time. So they will have 2 pointers, which is this NBP and NEP. Okay, so first of all, we will point this NBP to the end of the current name string, because this current name string contains a directory name, right? Because this is we check this file, it is a directory, that's why we passed it inside this function. So what we want to do is we will append the file name after this directory name. So we will first move our pointer to the end of this directory. So therefore, this pointer later on, we can append the file name underneath it. The first thing we'll do is append this slash at the end of the directory. And then we will do some basic check if the name is too long or if it's not going to open. If that all works, we're going to iteratively add one file at a time into this thing. Okay, so we'll use this the read function. Use this file descriptor, the buffer for the content of the file, as well as this how much size of the buffer, right? Here we are going to handle two error situation. One is this no slot is in use, so that means like we haven't haven't find the ID number for it yet. So that way, it means we are running out of the inode space. Otherwise, situation is if this is the current folder or the parent folder, we're skipping those information. And we only handle is the file name inside this directory. Okay, so for each file name, we're adding the name to the end of this MBP, right? The MBP was pointing at the end of the directory, but we passed it into another pointer. All right. The reason we do that is we're going to do this for multiple times. Every time we run this for loop, we will make a copy of this pointer. So this pointer is always pointing at the end of the directory. And then we append the file name at the end of this directory to make up the whole path of our file. And at the end, we will just going to add a new terminator to the end of the string to finish this one. All right, so if we look at the where? Oh, here. Yeah, so if I list it again, right? So our function will do something similar like this, right? So it will print out the directory itself, and then it will pass this directory name into our directory function. So we have a pointer always pointing at the end of this position, and then append whatever file name under our directory to the end of it, right? Then print out the entire thing. And then we do it again, insert another file name at the end of this file directory and print out it again. And we just keep doing that, but skipping this current folder as well as the parent folder. All right, so yeah, so again, we just show you this example that we're reading files iteratively, right? And we have used a few concepts we have taught in the class, such as like how the structure works, how the pointer works, as well as like how to do the string comparison and read and close file, right? Okay, so this is the first part of this lesson. So we talk about the essentially the file system itself, and we have give a try on how it works in the UNIX system, and then we look at the code behind to make it work. You're not expected to program that, but similar to the assignments for question 3, you might have some matching question to put the right code in the right location to show that you understand those code or similar code in a similar way. All right, so I will just end the lecture here. The remaining time, what I want is for you to fill out the course evaluation. So today is the last day for you to submit a course evaluation. So I want you to take your time to submit it before the end of the day. So in this lecture, I'm trying to make some changes to the format have been done before, right? For one, I have incorporated the in-class exercise. You can try out some code in a very limited time, but just to help you understand the concept, as well as I developed those Kahoot quiz to help you review, reflect what we have learned before. Moving forward, next class, I will finish up this slide. This is our last lesson. And then we have 3 more classes remaining, right? The next 2 classes in the next week, we will have some exercise question for you to practice and prepare for your final exam, right? So in our final exam, we'll have 6 programming questions, all right? We will practice the 6 program questions cover 6 like a main knowledge topic. So we'll practice those 6 topics through those exercises. So prepare you for that. And one last lecture is just for Q&A. If you ever had a question, you got stuck with anything.